Hello everyone, this is a recorded presentation of our paper titled Fair Visual Recognition in Limited Data Regime using Self-Supervision and Self-Distillation that has been accepted in the WSEB 2022 conference. My name is Pratik Mazumder and I am a PhD student at the Indian Institute of Technology, Kanpur. My co-authors are Dr. Pravendra Singh and Dr. Vinay Namboodiri. Deep learning models have been used to solve several real-world problems. However, they need to be trained on large volumes of labeled data. The training data often contain several types of biases, and deep learning models capture such biases and make biased predictions. Researchers have proposed several approaches to mitigate bias in deep learning models. However, these approaches generally assume the availability of large amounts of training data. In this paper, we empirically demonstrate how a limited training data severely increases the impact of biases on the model predictions and decreases the effectiveness of bias mitigation approaches. We propose a novel approach for addressing the bias mitigation with limited data problem that can also complement other bias mitigation strategies and improve their performance significantly. We propose a novel approach that uses self-supervision and self-distillation to mitigate the bias present in the model. Self-supervision and self-distillation are used for improving the generalization ability and representational quality of the model. These techniques help the model to learn useful and discriminative features from the training data, thereby minimizing the impact of irrelevant features. If the training data is biased due to any unwanted correlations, these techniques will also prevent the model from learning such biases. These techniques are also effective in the limited data setting and can easily help the other bias mitigation approaches. In our proposed limited data bias mitigation approach, we use a self-supervised task as an auxiliary task. Specifically, we use the SimSciM as the auxiliary self-supervised task. SimSciM trains the network to bring two slightly differently augmented views of the same image closer in the representation space. Our limited data bias mitigation approach also uses a self-distillation procedure which involves transferring useful knowledge from a trained teacher network to a student network that has the same architecture as the teacher. The self-distillation process also does not require any additional data, making it very much suitable for our approach. We first train a teacher network using the cross-entropy loss for the standard classification task and the SimSciM auxiliary self-supervised task loss. Next, we train a student network that has the same architecture as the teacher. We use the standard classification loss, the SimSciM auxiliary self-supervised task loss, and the self-distillation loss to train the student network. In our approach, we consider the benchmark datasets that are used for bias mitigation problem. However, we take a limited data version of these datasets while maintaining the same level of bias. These are our experimental results. We observe that for all these datasets, our approach is able to significantly improve the performance of the baseline model and also significantly reduce the bias score of these models. Further, we also observe that our approach is able to significantly improve the performance of the bias mitigation approaches in this setting and also significantly reduce their bias scores. We perform experiments over different levels of skew, that is different levels of biases, and we observe that our proposed approach is extremely effective for all levels of bias. We also perform an experiment in which the entire training data is available, and we observe that even in this case, our proposed approach significantly improves the performance of the baseline approach and also significantly improves the performance of the state-of-the-art bias mitigation approach. Thank you for watching our presentation on fair visual recognition in the limited data regime using self-supervision and self-distillation. It has been a pleasure to present our work here. Thank you.